Good morning, good afternoon, or good evening, depending on where you're joining us from. Welcome, everybody, to day 2 of the very first ASQ Synergy for Success Conference, Driving Excellence Across Industries, a technical community-sponsored conference. We hope you're feeling energized and ready to dive into another day of insights, innovation, and connection. We're so glad and excited that you've joined us. My name is April Thomas, and I have the absolute pleasure of being one of your hosts for this incredible event. This event brings together thought leaders, innovators, and passionate professionals from across industries to learn, connect, and be inspired. Trust me, the next 2 days will be packed with insights and conversations, along with moments you won't want to miss. We're truly honored to have such a dynamic community coming together. Thank you to the divisions who are responsible for taking a vision of a joint division conference and bringing it to life. Quality management, design and construction, software, energy and environmental, and government. And to the amazing program committee who volunteered numerous hours over the last year to bring this experience to you. We'd like to thank our sponsors, QI Macros and ASQ Lean Enterprise Division. We're thrilled to be able to welcome a keynote speaker who truly understands what it takes to lead through complexity with clarity and confidence. In a world of shrinking timelines, global pressures, rising regulations, and rapid change, system breakdowns can feel like they're inevitable. But today's keynote will show us another path, a path where organizational excellence and systems thinking can turn challenges into competitive advantages. Peg Pennington, president of Moore's team, will share how leading organizations are responding to complexity with robust, sustainable processes, giving us a powerful lens into how management systems play a critical role in navigating uncertainty while building lasting quality and resilience. This practical wisdom is for today, along with the future. Please join me in welcoming Peg Pennington.
April, thank you so much for that heartfelt welcome. And I want to say thank you to the ASQ community for this midsummer break. It's great that all of you are here in the audience continuing this learning journey. And as April said, I'm talking about complexity today. And I think many of you in this audience today are thinking about, I work in a complex organization and it's only becoming more complex. So, how do we actually improve process in the face of all that complexity? So, I want to start with just a simple concept here that Michael George talked about in his book, Conquering Complexity in Business. And he actually talked about complexity. He gave an analogy that it's like high blood pressure in your organization. And if I asked everybody, what's high blood pressure called? Some of you would say it's hypertension, but other people might say it's the silent killer. And people call it that because you could have high blood pressure for a long time and you don't know it. And while you have that, it's doing significant damage to your heart and your arteries. So complexity is just like that in your business because it's the silent killer. It doesn't show up on an income statement. There's no line item on your profit and loss statement that says, hey, we're amazingly difficult to do business with, or your balance sheet, or a market share report. But what complexity does to your organization is it reduces profits, it slows response time, it creates inefficient operations, and it actually creates quality issues. Some of you may remember seeing this toy before. It's called Newton's Cradle. It's all about physics. So you lift that ball and the energy goes through those other balls and causes that, ball in the end to move. And this is how complexity is. You don't see the actions that impact the actions downstream. So we want to understand that a little bit more. I'm going to ask some of you to type in a response here. This is a book. It was published in 1984 by a gentleman by the name of Charles Perrault. He was a professor at Yale. And for some of us that, maybe that were Gen Xers here, uh, do you know what that picture is on the book? If you type that in the Q&A, I'm just kind of curious how many of you might recognize that picture. Give you a second there. I see lots of good mornings. Ah, Space Shuttle Challenger. There it is. Yep, that was the Space Shuttle Challenger that exploded. So think about the title of this book, Normal Accidents. So we're all in this quality community here. And this professor writes this book, Normal Accidents. And that's not two words we want to ever put together, right? Because we want accidents to be abnormal or out of control conditions. So Perot, he postulates that in these, this is back in 94, he does his research. He's looking at the Challenger, he's looking at Three Mile Island, he's looking at the Bhopal Union Carbide um, chemical spill. And he says, hey, in these tightly coupled complex systems, that there's these technological failures, these catastrophic accidents that are going to be normal. And as a quality person and a lean thinker, I want to think, no, that can't be. So let's look at how he defines complexity and try to understand these unforeseen and what he's saying is unpreventable accidents and see how we can put in systems in place to overcome that. So, in his book, Normal Accidents, he gives us this framework to kind of think about um, how do we think about complexity in an organization. And that first level, let's just start at the top. He thinks about interactions. So, we go from simple linear interactions to complex interactions. And simple linear interactions are going to be like your dominoes. They are in a straight line. One thing happens and it's clearly causes the next. The steps are predictable and they're easy to see. So you have clear cause and effect. And as you move over into this area of complex, that's when interactions become more tangled, more like a tangled web as opposed to linear and lined up. One change might affect several things at once in ways that are not obvious. It's harder to predict what will happen, and problems can spread in unexpected directions. Kind of like your emergency department. So you go into that emergency department, and there's many complex interactions. To move a patient forward, you have to have knowledge from the lab, from a specialist, from a hospitalist. Inside of all of that, there's many other patients that have a lot of variability and the variability of when you actually arrived at the hospital. So you have many different pathways in the interactions are not rigidly sequenced. And a lot of times they have unique outcomes. So you're going from linear to complex. Then on the left-hand side, he talks about connections or coupling. Coupling was the actual term that Charles Perrault used. So they're loose or tight. So if you think about a loose coupling or a loose connection, there's a lot of buffer between that, either in space or time. Okay, so if I have a very loose connection between my dominoes, I have one domino fall and the next ones do not fall because they're not connected. So the tighter the connection, the faster those dominoes fall. And it's like I don't know if you're all out there watching the Peloton and the Tour de France, but there's a picture of the Peloton. And if a biker falls in the middle of that, there's going to be about 20 bikers behind them fall because they're so tightly coupled. So, tight connections, they tend to make systems riskier because things happen fast and there's very little room for mistakes. So, a small failure can trigger a chain reaction before anyone can intervene. And we move into this upper quadrant here where Perot says that some technologies, they're going to be prone to having this normal accident because we're operating up here in a complex environment that's tightly coupled. And when things happen, they happen very quickly. You can look at, here's an example, would be the BP Deepwater Horizon drilling rig that exploded in 2010 and discharged 4.9 millions of barrels of crude oil, was the largest oil um, disaster in U.S. history. But what were all the failure points? They were technical failure points. They were operational failure points. Emergency systems failed, and they failed. Obviously, this was a very preventable incident, but when it started to fail, it went very fast, and 17 people lost their lives, and there are countless injuries. So, thinking about working in that complex, tightly coupled environment, um, you have to have really good systems in place to avoid these kind of failures. So, where I want you to think about where your organization is working. If you're in this lower quadrant, where I put manufacturing in there. So I kind of think about this as discrete manufacturing. You're making parts. As you go from discrete manufacturing into a process industry, chemical, that's going to move you north because you're more tightly coupled when you start making chemicals, whether it's paint, food, process industries. Um, if you're in this, you're complex but loosely coupled. That could be a research lab, a military mission, a college inside a university. It's complex within that tiny environment, but that's part of a bigger system. So we have complicated, I would say complicated systems are going to be power grids, air traffic control. They have many moving parts, but they operate in a patterned way. Like your electrical grid, it's possible to make accurate predictions about how a complicated system will behave. That's why flying is incredibly safe in the United States, even though we just kind of had another near miss with the B-52 bomber in the SkyWest Delta flight about a week ago. But flying still remains incredibly safe because we have predictable steps and they follow certain patterns. But how do you go from complicated to complex? It's the variation in your systems when processes are not in control and there's system interaction between that complicated web. So things become more unpredictable. Think about a hospital, a nuclear power plant, our financial systems. They behave in nonlinear fashions. So small changes in one part can cause a disproportionate effect in other parts of the organization. So that's kind of the difference between complex and complicated. And then we want to think about like what's the impact of lean? So lean is in one instance it moves you north, okay? It moves you towards the top from a loosely coupled system to a more tightly coupled system because it's removing buffers. Okay, it makes the sequences more time dependent. But in lean, you're trying to build that robustness in, at each step. So we understand why we're holding inventory and how much inventory we need to hold. And we're understanding what our supply chains are. But you can see during COVID, we had a lot of lean systems, but there was that um, changes in our supply chain had extreme impact on the downstream effect of our supply chains. I think most of you on this call, whether you're in manufacturing or service organizations, you're going to say, hey, we could have been, 10 years ago, we're operating in this loosely connected environment, linear, but the forces of business, our strategic decisions, some imposed complexity are moving us into that upper right hand quadrant. So I'm just going to ask you, I'm going to say that's probably true. What are some of the things that are happening in your organization that move you into that business complexity? So you start operating in that upper right hand corner where we know the chances of failure become a little bit higher operating and up there because you have more variation in your process. So if some of you that are on this line or on the Q&A, just type in there, what are some of the forces of business that are pushing you up into that upper right-hand corner? And if you're moving into the left-hand corner, that's great. Oh, cloud computing. Oh, I'm still. April, do we have some people typing in here? Geopolitical issues, 100%. Increasing customer demands. I'm always telling people, do you think your customers are going to have more SKUs, keeping units in the future or less? It's probably more. AI. Okay. Yeah, these are all reasons that we move into um, that upper right hand corner. And that's something that we want to understand and actually try to improve and reduce those effects. So, is there kind of a secret sauce to this? I don't have, quick and easy answers for you because a lot of this is it is hard work. You've been at this a while as quality professionals, but let's think about things that you can do to improve. So when we talk about organizational complexity, um, where you decide to operate, how many products do you decide to produce? What countries you're in? All of these strategic decisions create complexity in your organization. And just as an example of this, if you have one individual, you add one individual to this loop. You have five people communicating, you have five communication loops, and you add one person to that communication loop. It goes from 5 to 10. Okay. That's how much you're increasing it. So thinking about the decisions we make leads to individual complexity, leads to, where we make mistakes at the shop floor level. So how do we combat all of this? Perot talked about something, he calls them premise controls, premise rules. And I like to think of them more as this overarching shared values. So these shared values, this is coming from the top down. I pulled this from Nordstrom's, who has incredible customer service. One rule, hey, use good judgment. when you're working with that customer to keep them satisfied. Um, but they allow their people to take back clothes. They allow them to make decisions at the store level to satisfy that customer, and then they have a feedback loop of working through, you know, how did we make the right decision? Let's learn from that decision. And another one is SpaceX. They have a serious no-go launch routine, and they are not going to launch to time pressure, social pressure. They're going to launch when that launch is safe. So the no-go conditions override any economic or scheduling pressure, and everybody in the system knows that. So that kind of one rule, what is that shared value that you have in your organization that's got to carry all the way down? And everybody knows that. And that becomes a premise rule for how our organization operates. Having a strong culture of safety, safety first, embedded from leaders all the way down to the organization, all the way down, to the bottom of the organization. And if your organization does not have a strong culture of, I would say, quality, lean, uh, I'd say the place to start is with your safety culture. It shows respect for the individual. We're not going to expect you to be taking calls in the car while you're driving somewhere. This is just not what we're going to do. And imbuing that culture throughout the organization. So let's get to that people system. And sticking with my safety culture, I think a wonderful example here was Paul O'Neill and taking Alcoa from a company that had lots of safety incidences to one of the best operating companies in the world. But he believed that he was a teacher, and I think you want to move your organization. Your leaders have to be teachers. They have to be able to communicate clearly. This is why we're taking the organization in this safe direction, um, that this is what our premise rules are, and building capability from the ground up. So leaders as teachers, and you can have all the great quality teaching, all the great lean thinking, and if it stays at that operator on down level, you're only going to make so much and significant changes. The leaders have to be engaged in this. When we think about team diversity, I have this great picture up here of Abraham Lincoln, and I think probably a lot of you have heard of that team of rivals. Um, Diverse teams are harder to manage within your organization. But complex systems, they're organic, and you need to make sure your organization contains enough diverse thinkers to deal with the changes and the variations that inevitably occur. So, what a diverse team, it overcomes this groupthink when we all start thinking the same way. And so when I talk about diverse, it could be diverse in terms of the functions that are included. It could be diverse in terms of the people that are included on the team. But when you have a diverse team and you're living with this complexity, that diverse team is going to bring up more potential risk that you don't see, because everybody has their certain mindset of what's you know they're seeing from their lens. But you bring somebody in from HR, you bring somebody in from maintenance or the quality department, and they're going to bring it a different lens on this process and helping to make this process better. So I believe having a diverse team when you're working on process improvement is absolutely foundational for making your processes better. making your environment safe for people to speak up. Amy Edmondson, she's from Harvard, she's written much about psychological safety. And what they determined is when you're in a large, say, academic hospital, different people show up for a surgery. So you might think every time you have this surgical team where everybody knows each other, that's not true. You have hundreds of physicians, anesthesiologists, surgical nurses. So each team that comes together for a surgery is unique. And they found the simple fact of having people go around and introduce themselves at the beginning of surgery promotes anybody during surgery. It gives them the ability to speak up if they see something that's going wrong. Because in many of these environments, a nurse might not feel that they can speak up to the surgeon. So it's important that the surgeon makes them feel psychologically safe so that they can say something as soon as possible if they, left something inside the patient or seeing something happening with the patient. So once employees feel safe, their self-confidence begins to build and they're more likely to speak up. And that's what you want to build a resilient organization is to have the ability to have people speak up. In a resilient organization, if we want to build that resilientness or, combat that complexity that we're building into our organization, you have to be a system thinker versus a people blamer. So you either approach this with this idea of, I can put up posters and make people perform better, or, it's about that naming, shaming, and blaming. And process thinkers are want to dial into that process instead of thinking about how did that nurse made a near miss or a medication error. It was what was the condition that nurse was in that created that opportunity to make that mistake. Oh, the Pyxis was down. Oh, we were working a double shift. Oh, I had a lot of patients assigned to me. Oh, these medications look alike. Let's look at that entire system to improve it so we can eliminate unsafe acts or, procedural errors. So again, going from this idea of naming, shaming, and blaming to let's really understand the systems and knowing posters are not going to impact process. So you can change the human condition. We cannot change the human condition, which is that all of us on this call today, we make mistakes, but we can change the conditions under which humans work. And as leaders of quality, that has got to be our thinking to eliminate that time pressure, understaffing, inadequate equipment, fatigue. So we should strive for comprehensive programs that are aimed at different targets, not the person, but the whole process. How do we improve that whole process? So I'm about to give all of you a test. Okay, so I think this will be fun. We want to see what is the cost of individual complexity on your work. So, what I would like you to do, you could do this on your phone or perhaps your computer, or even I would just say you're at your desk, get out a sheet of paper with a pencil or a pen, but you're going to need something to write with. So, I'll let you scramble around. You didn't know there was going to be a test, but I think this will be a fun test. Okay. So while everybody's getting that, let me give you the rules of the test. So I'm going to break you into teams. Um, if your last name begins with A to L, you're going to be on the Scarlet team. If your last name begins with M to Z, you're going to be on the gray team. So Scarlet, the beginning of the alphabet, gray, the end. So in a second, I am going to show you a group of letters and numbers that you have to memorize while we do another task. You can't write it down. That's the tricky part. I know, like, some of you are going to look at the combination and you're going to want to write it down. The most important thing you can do is to remember this list of letters and numbers. That's the first quality benchmark. If you forget it at the end of the task, whatever you did does not count. You have to have this quality. So I'm going to give you that. I'm going to let you look at it for 10 seconds. Okay, and then I'm going to get my stopwatch out to time this. So Scarlet team, you're on the top. Gray team, you're on the bottom. Okay, we're going to move off of this slide here in a second. You're getting this memorized. Now, uh, for the next 60 seconds, I want you to write down as many examples that you can think of using the word bear in it. And I'm going to give you two to get you started. I'm going to give you 60 seconds and you write down any combination using bear. And then when I say stop, you have to write down that number letter combination. So you can all put these two examples in: gummy bear and grizzly bear. Go. Okay, stop. And now what I want you to do, Scarlet team, write down your number letter combination, and gray team, write down your number letter combination. Give you a second. Okay, so the first thing is, let's see if you got your number letter combination right. Okay, Scarlet team, I'm hoping that you got that. I want to hear from the gray team. Gray team, how'd you do on that number letter combination? Did you get it? Give me a thumbs up or a thumbs down. Did you get it correct or incorrect? Yes. Some of you, yes. Okay. So for all of you, put in, let me hear from the Scarlet team first. Oh, no, let me hear from the gray team first. Gray people, the gray team that got it correct, they were able to put it in. How many bear type of ideas were you able to think of? Maybe 7, 8, 9. Let me hear from the Bears or from the gray team. How many did you get correct? Or how many bears did you able to think of? 8. Okay, I'm seeing a couple eights, sevens. Okay, that's a pretty good number right there. Okay. Now, great people stop. I see an 11, Louis or Lisa. That's pretty impressive, but I think on average we're hitting in about the 7, 8. Okay, great team stop. Scarlet team, I'm gonna go with you got this correct, the A12. Scarlet team, if you could put like an S and then put how many you were able to think of. How many bear ideas did you come up with? If you're on the Scarlet team, put S and then your number. So I know you're on the Scarlet team. Okay. I hope all of you are seeing that. Look at the difference. We're going from, 8, I had 8 ideas to 12 ideas. And I assume just looking at the chat, there was a pretty decent fallout from the gray team that did not get that combination correct. So there's a quality failure and then this innovation idea. I'm asking you to do something innovation to think. So when we're asking people at the level, we create a lot of complexity for your associates. You're stealing their innovation because they're trying to hold so many ideas in their head and their quality goes down, their innovation goes down. Hopefully, you got some of these good ideas right here. I don't know if anybody got way off the grid like bear aspirin or because I give you those bears, the bears, but did you think about barefoot, Bear Stearns, the golden bear? I'm from Columbus, Ohio. I had to put that in. Huggy Bear, if you're a Gen Xer like me, some of you might remember Huggy Bear. But you can see what is the cost of complexity on the individual. You're stealing all of their innovation by making them hold too much in their head at one time. How do we combat that? You got to stop multitasking. I know we all think, we can multitask, but our brain is not set up to do that. It's really limited the amount that we can put in at one time. So we put in many things and you skip a step in line, you forget a step. When you're in a highly complex environment, that can have a huge outcome during your into your process. So what do you have to do? You have to build simple direct pathways. Typically, simplicity does not precede complexity, but follows it. You create complex systems and then you work to reduce them. How do we reduce them? You have to understand how processes flow. You have to create maps, and we're not only just create them, you have to work at them to eliminate silos, understand handoffs, make them very simple, make it explicit how work flows, when work stops, and you know, what are the specific outcomes from that? What else do we need to do? Root cause analysis. We have to learn from the past, how not and not just paper over things. We have a simple fix quickly. Um, I had an example from a hospital where on an ortho floor, they saw uh, um, an increase. They were using catheters. They saw an increase in infections and they wanted to eliminate that. So they said, well, we're going to take catheters out sooner to stop infections. So no sooner did catheters come out sooner than guess what? Patient falls went up. So they said, oh, well, we need bed alarms. Let's get bed alarms. So anybody in here in a healthcare system will tell you they're kind of complicated. And what happens, patients hate them. You move around, the alarm goes off. Sometimes they're not set up properly. Patients' families turn them off. So there's this over reliance on the bed alarm to tell people, hey, they're getting out of bed, the patient falls. So falls went up even more. So then they like, okay, I have to get to this deep understanding of what's happening here. And you start looking at, I'm on that patient call button, and some responses were over 30 minutes. So patients were becoming inpatient, and that was what was creating that, hey, I got to get up. I want to go to the restroom, and let's look at what is our response time and how can we mitigate this long response time to decrease patient falls. But wow, they went through 3 cycles of trying to put countermeasures in there before really getting to a deep understanding of that. So root cause analysis, I can't say enough about it, how important that is to understanding what your system is and putting in countermeasures. Learn from the future. It sounds kind of weird, but Huggy Rao, he wrote this book, Scaling Up Excellence, and he says we do postmortems. Why did things fail? We also need to do premortems and understanding when we're changing process, how could that process fail in the future? And do a detailed look at, what could we do? Hey, when I have that diverse team together, you're putting in that countermeasure. They might see things, hey, this might not work as intended, but it's go slow to go fast. Everyday problem solving. when I, a lot of us are working on projects in our organization, but we have problems that are coming in every day. I call them sand, the sand that slows down your gears of progress. And that sand is the innumerable small image or issues that wreak havoc on your daily work. Applications that always have errors, progress updates that arrive late, workloads that skyrocket then crash. And that sand is kind of ubiquitous at the front line. And you have to have people that can solve problems at the front lines, close to where the work is done, and be able to get back to root cause. You have to solve problems faster than you create them. So, building that problem solving capability into your organization is supremely important to building a robust organization. And shortening feedback loops. I put that Flint water plant in here. Some of you may remember this. This happened in 2014. Flint was, this is a really good example of a complex organization and a large system failure. Flint was their city was in dire straits financially, so they decided to get off the Detroit water system. They thought that they could use the Flint water system. It was going to be cheaper, so they switched their water source. And they had some original, like at the very beginning, there were signs that this water is more corrosive. There are problems with the Lake Huron water. And what happened was that water was so corrosive, it created lead in the water. And that went on for an entire year in the Flint water system, even though there was independent investigators. But thinking about it from that original Charles Perrault, it was tightly coupled. It was changed really quickly. They had slow signals in their feedback loop. They had a lot of bureaucracy, so a lot of complexity in that system. And that long feedback loop allowed many people to become ill, and it created a huge problem for Flint. So when we have these complex organizations, we have to shorten what that feedback loop is and have feedback loops all the way through your process. This takes hard work. So I said secret sauce, and I can't say, hey, here's the secret sauce other than hard work of, you know, having your leaders have that their shared values communicated down through the organization, looking at your processes by value stream mapping and reducing complexity at the source, looking at standard work, for the operators and making sure you have simple, direct pathways and you're not asking them to do more than they could to create, poor conditions. These all take hard work, but I know that people on the call, you want to make these processes better. You kind of have to dive in and get your hands dirty to say, hey, we're operating in this complex condition. We can go from complex to complicated and then start dialing it down to have those great processes that are safe, they satisfy your customer, and they produce high quality um, products and services for your customers. So I want to thank you, and I want to ask April, you've been monitoring that. I don't know if there's any questions that people might have for us today.
I am taking a look and I am not seeing anything that has been posted directly into the chat. However, if you have a question that you would like to be able to ask Peg, since we've got about 15 minutes of time, we're happy to do that. We will also have an opportunity for some deeper discussion in question and answer chat following this from 11 until 12 as a roundtable and networking session with Peg as well. So we'll give you a couple of minutes to see if there's anything that you that anybody wants to ask, and place that in. You'll see on the right-hand side of your screen, there's a spot that says Q&A, and there's one that says chat. If you can place it in the one that says Q&A, that will help me to be able to more quickly see any questions that get placed in there.
And I wonder if anybody was impacted last year when they had the CrowdStrike rollout. And if you remember, I think that was in July, right about now, they rolled out, CrowdStrike rolled out a security update, and organizations all across the country woke up to the blue screen of death. There were hospitals that had to go and reset every computer, but the organization that was hugely impacted was Delta Airlines, and they were down for days. So that's how fast that one update traveled through the system.
I don't see a question, but I see a note of appreciation. Thanking you, Peg, for comments about indicating that it's responsibility as quality leaders and professionals to remind our organizations of this. I do see a question. What is the role of FMEA in anticipating and simplifying processes?
Yeah, I love the failure modes effects analysis. If you haven't heard of that, it is a tool in our quality toolbox. When we look at perhaps you're going to improve a process or even just understand a process better, you would look at what are potential failure modes within this process. So even today, we're going to have this webinar with you. And a potential failure mode was, what if Peg can't present? So April's got my deck. So we look at how can I mitigate that risk of a potential failure mode? What if Peg's internet goes out? That would be very horrible, but I could back up on my phone. So we look at what are potential countermeasures to things going wrong, and then you can actually, it gets into greater detail where you can look at what's the severity of that risk, what's the occurrence of that risk, and what's our ability to see that it's failing. And it gives you a risk priority number to go look at. I think that probably most people on this call kind of think that way already. I'm going on a trip. I don't want to lose my passport, my phone. I mean, do you get out of your Uber and you're like, I've got to make sure I have my phone in my hand when I get out of that Uber, because if I leave the phone in the Uber, that's going to be a really bad situation. So we're building in all kinds of countermeasures, but FMEA is really great tool, I think, for looking through that. And I when people talk about the Toyota production system, I think is something to be studied. What and we look at applying lean principles to the value stream, but within that value stream, they also are signaling when things go wrong. They have built in a lot of capability for not just that first round of things going wrong. What is that second round that things that could go wrong of improving that process?
Yeah, we've had a number of questions come in. I think another one um, that's a great one to ask is, do you have any recent examples of initiatives to reduce complexity in your organization at Morstein?
Yeah, 100%. I was actually thinking and talking about this today, like two things that language issues create conditions for us because I work for a company and we do data analysis as well as e-learning, and our e-learning is in 9 different languages. So I would say it's complicated, not complex. But having that in 9 different languages, and we think about all of our statistical terms that you get into multiple regression and think about all the terms that are baked into that heteroscedasticity. I mean, how do we say that in Portuguese or Spanish or Polish? So what we've tried to do, here's some improvements that we've made. We have 100 base terms. And some of these lean terms or statistic like mean or average, those things matter how we're talking about them statistically. So you can use translators, but that's not going to be good enough. So we go out and say with just one language, I'll take Polish and find people that are in our community and say, okay, here's these 100 terms. We have to get these terms right. Okay. And go through and look at, hey, can you tell us what do you call these 100 terms in your language? And then we look at agreement of those terms and then go back and make sure that we're consistent throughout that process of translating because I think in the future you could probably put this stuff into we use DeepL. I'm not saying that's the one to use, but it is what we use into these translators, but it really matters between I just was talking this morning where it translated the DeepL. We had defect free, and DeepL didn't get that, didn't really understand that, so it just translated the word defect, not defect free. So going through and then having people review that before the content goes out. But language translation can be an issue. Yeah, that was a good question.
Yeah, and I think we've got time for one more question. How do you measure the level of complexity?
Oh, there is a formula for that. I don't know it off the top of my head, but you could you start looking at nodes, like how many nodes are coming together to get to that point of making a decision. And wow, I want to give you that formula, but I don't know what it is off the top of my head. But it is kind of looking at the nodes and then the variation on those nodes. Because you could have a process that's absolutely in control, but then you have processes that have a lot more variation to them, which gets translated down to that node. So think about I have two processes with a lot of variation coming together. That variation, that unknown effect of that is what creates that out of control condition. So good question. I apologize that I don't have the answer. And I was going to before we leave, I had one last slide if I'm allowed to show it.
You do. You've got time.
I want to talk about just to leave everybody with, and thanks for all your participation today. And as April said, if we have a chat after, that would be great. I love talking about improving processes. In 1935, the U.S. Army they made a plane. It was called the B-17. This became the oh, I'm trying to remember what the name of this. It was not the B-52 bomber. It was called the Flying Fortress. And when the original Flying Fortress was launched, it crashed many times and it took many pilots' lives. And they wanted to go back and redesign and do everything. And this is when the pilot, and they kept saying, hey, it's pilot error, it's pilot error. But then the pilots got together and said, this is the first plane that was actually so complex. They couldn't hold all the information in their head. And this is where the check sheet came from. Okay, so going back to like 1935, the B-17, the Flying Fortress, their solution was just a simple check sheet. And we know the check sheet has kind of stood the test of time for helping us run through and reduce complexity. So all of these things that we study, they truly matter and help us to improve process. And I hope that something that we've talked about today to improve process has given you motivation to make a change in your own organization.
Well, thank you so much, Peg, for a really inspiring and I think thought-provoking keynote. Right? Thinking about these four systems of strategy, people, problem solving, and daily management working together in synergy to be able to support looking at simplicity as well as excellence. And I love this concept of how diverse teams are needed to be able to address that complexity, to address some of those challenges and concepts that maybe there's those unknown risks because each perspective is valuable and helps us see things a little bit differently. And it made me think about Deming's quote about, right, a bad system or process will beat a good person every time. So what I'd like to invite individuals is to be able to think about and carry that inspiration forward with you as we move into breakout sessions. You can go back to your home screen or the lobby and select from one of the three sessions to attend, or I invite you to join Peg and I for those questions that maybe you wanted to ask that we didn't have an opportunity to address in our keynote today. To be able to join that, you'll go to your home screen and you'll select networking, then roundtable and keynote meet and greet. It'll be from 11 until 12. So I would like to invite you to come back at 2:45 as we do a short close for our day and look forward to hearing and seeing your insights from all of the learnings today.